Hi everybody, welcome back to this new review episode for the STM32 tutorial. And today we are going to learn how to control the state of a pin of the STM32. We are going to do all of this from scratch. So from our tutorial perspective, we are going first to take a look at the circuit, the electronic circuit that we are going to use for this tutorial. After that, we are going to see how to enable the port A. This is connected with the previous video we have done, but don't worry, we are going to have a quick review on this first. After that, how we are going to set up the pin. Then we are going to set the port or set the pin as a high or low. Finally, we will have another example of the previous 4 steps so we can get a kind of more practical example. And then we are going to have another example which will be a little bit different because the LED is integrated within the PCB. For today's example, the board that we are going to use is the black pill, and the microcontroller is the STM32F411CEU. So let's start and begin our first part, which is reviewing the electronic circuit. Within the circuit that you see in the video, we are going to connect the port A pin 0 with a 220 ohm resistor and then connect that one to the red LED. Careful to use the right value of the resistor because if you make a mistake, you may destroy the LED. After that, we are going to connect the port B pin 7 to a blue LED, which is here. And same, we're going to use a 220 ohm resistor. And finally, the PC13 or the port C pin 13, which is here, is connected to a blue LED. We don't know what is between them, but that's within the PCB. Okay, so without waiting, let's start, have a look to the code and start our tutorial. Let's start our new fresh program. So let's open the Keil uVision 5 and go to project and new uVision project. So I prepared the empty project so we can start from scratch, and let's call it output setup, for example. So or GPIO out setup. Okay, and let me add some underbar to have a little bit more meaning to what we do have. GPIO output setup. Good. And as we shared, our microcontroller is the STM32F411 and then the CEU. Okay, unfortunately, we do have only one unique microcontroller. Okay, perfect. We are going to choose the core, and also from the device perspective, we are going to select the startup. We do have kind of warning, just a warning, and I will show you later on what will be the having this sign here. What will be one of the side effects of having this sign? It's just a warning. It's not a problem or an error by itself. Even if you write resolve, nothing is happening, so you can just put OK for the moment. And we start. So we are writing in the target the name of our target, and we would like to be as specific as we can. And we put CEU like this. And then let's add our app source or our source file. So we call it main here. And let's change this one to just app. Okay. So we go here and we put just app here, and we do have our file. I wrote something wrong, so let me try to see. I will remove it and create a main file. And here we call main. Okay, so let me close this one as we don't have it. So we do have immediately a warning, and let's start by just creating our just the main function. So int main, and that will be a void as we are going to not insert this function will accept no argument, and we should remove that warning sign. So we are good. And also let me make the size of screen a little bit bigger so you can see the code. So our first step now is to enabling the port A. And to do that from a pure bare metal perspective, so let me open the reference manual. And what we need to do is to go for the RCC. And this is what we have seen in the previous episode where we understood better about the architecture. So let's go quickly in the description and see this complicated picture. So compared to the previous microcontroller, this one is way, way more simpler. And we see here that our AHB1 bus is directly connected to the GPIO ports. Whatever from A to H, they are driving all the ports. So if I check quickly there's no other GPIO. So the GPIO port will be controlling the simple function of turning on or off the pin of the microcontroller, or also making him as a reading microcontroller. So let's go back here. So we need to go for the EHB1 and say to HB1, you can open the road to the port A here and make it usable. We go here and we need to go for the reset and clock control. And based on that, we go to the RCC registers, and quickly, if we go through all those registers, we can find that there is AHP1 peripheral clock enable register. So we are enabling those register. It's kind of a plugging. It's kind of a plugging, or just having a switch to switch the port A. And if we go here, this is almost self-describing itself. This register have here GPIO A enable, and this EN is for enable, and that's the first or the bit number 0, just to be quite accurate, is the bit number 0 of this register. So let's go back to our code and start trying to find. So this register have a specific address, and I need to show it just you understand. So it has here an address offset 30, and if we go back here again and we go to check through the memory mapping, that's somewhere happening here, here, and with a certain offset. Of course, you can create a pointer to this register and check it by yourself. However, there's a kind of a very helpful library that it's not actually a library with functions and program, but just some people already has mapped all this register. This is very useful. I don't think that understanding this one from scratch does help or does add a huge value, but some people are just put it an address or a value, or how to say, pointed on those addresses, so it's much easier to do this job. And to get this library from here in devices within the system STM32F4, if you go a little bit here, you will find somewhere an include, and this is the include that we need. So include STM32F4 XXH. So this library will be directing to the F411 .h. So we need this one. That will be a general library that we can use, and that will be helpful to switch between microcontrollers. Okay, so by doing so, if I click RCC, and this is what we have been seeing in the previous episode, and I just put the array, the structure pointer, we have all the names here. So it's much easier to find the name, and it's AHP1 enable register. This is what we need to do. Okay, and we said it was the bit number 0. So there's one way. We can start by putting just equal to 1. This would be working perfectly with no issue at all. So if we put like this, that would be working no issue. However, this is really not a good practice, because if we put equal 1 for all the other value of the register, and if we do have a whole program that is already using some other peripheral, that will put all the rest in 0, and only GPIO enabled to 1. So as a good practice, put the or equal, so this one will impact only the bit number 0. Okay, so here we have completed enabling the port A, as simple as it is. So let's put it here, enabling port A. So next step, yeah, and another thing, you see this kind of comment here. This is because the compiler that we use, and as I told you, we do have some warning for some kind of a discipline. However, you are writing your C. So if you would like to remove this error message, you should better put your message like this, the comment like this one, and it will disappear. But if you are like me and you are a little bit old school, just to show you another way, there's another kind of error that will appear if you are using a binary number. So that's not an error, but a warning. So if I would like to set up this one as a binary number like this, I should have some warning happening here and say there is this GNU extension that's generating some trouble. So how you can remove this one, you just go to this option for target here, and for this option of target, you just select 5, and then you select 6 again, and you put OK. This will resolve, and you have the warning disappeared. So anyway, this is not really impacting how your program will be working. Okay, so we completed enabling port A. So next step, let's go and start now having the setup of the pin 0 as an output. So now we enable the port A. We are going to port A pin 0 as an output. Again, to manage the pin activity, we go to the reference manual and we select this general purpose IO. So this is here where you can find all the data, all the information related to the general purpose IO, but also the register map and how the register are working. So the first register to set up the pin as an output is the mode register. So let's make this one a bit bigger to understand how this register is working. Let me zoom like this. So it's a 32-bit register here. So and each 2-bit represents 1 pin. So we are going to try to select a special mode for the pin, and we do have 4 modes. The first one, if those 2 pins are 0, it means we would like the pin to be an input. If the first 2 bits are, or these 2 bits are 0, 1, then it's a general purpose output mode. Then if it's 1, 0, it's alternative mode function. And after that, finally, if it's 1, 1, then it's an analog mode. We are going to see all of them one by one in great details. And each 2-bit together represent the pin number. So for example, the mode, this one, the mode register 0 is about the pin 0. The mode register 1 is for pin 1, etc. Until the mode register 15, which controls the pin number 15. Okay, so what we need to have here is we need to apply just a 0, 1 to this register. So the first 2 bits that controls the pin number 0 of the port A will be set up as an output. So let's go here, and what we can put is, so this is GPIO, and this library gives us also GPIO. As soon as I click this one, we have the GPIO A, and if I put like this, I go to the mode register, and I will make it or equal, same thing here, and that will be the 0, 1. So we can put the 0B1 like this, and I think no, it's a 0, 1, not 1, 0, like this. And here we are setting up pin 0 as output. However, this is good, but there is a better practice against what we are doing here. So now we are controlling and trying to change or to set up the pin mode, but we don't know what was the previous selection of this mode. Maybe the mode used to be in analog mode or alternative function. So if we apply our OR equal, that will give us something, not the desired value. So what we should do usually is before applying the desired value, what we should do is to apply a value that will remove or reset the bit value here. So what we should do, we can just copy, and we have seen this quite in details in our binary operation. We will put and what we will put is the tilt or the reverse operator of the 0B11. Okay, let's put like this. So this one will, what will do, it will apply a 32-bit number. It will apply a 32-bit number that will have ones until the last one, which will have 0. Okay, and this one is just resetting the values. Okay, so now we set up our pin as an output, but in a clean way, so we don't have any error or any issue happening. Perfect. So now we finish this step. We can go to the next one, where we are going to set the port A pin 0 to put it as a high. And just for summarizing or resuming what I say, I usually port A pin 0. Let's call it PA0 just to make things faster. To do so, so now we set up this one as an output. We still need to make some kind of a setup so we can have the behavior that we want. First of all, we can go through the GPIO here, output type. In the output type, we do have the push-pull or the open drain. Usually, no, we need always to have it as a push-pull and avoid to have it as an open drain. So the reset value or the initial value of this register is always 0. But to be sure, because if we do have this open drain, we will not have the desired functioning of our pin. So we usually should apply the 0 where we want. So let's go here back and what we are going to apply. So let's put the GPIO and here the output type. And we will put and equal, and we will put the reverse or the tilt operator of the 0B1 like this, and just put like this, and here set up the pin as push-pull PP. Okay. After that, let's go again. There's a few other small setup. This one is the speed register. So this speed register is not impacting directly the desired way we would like, but for some application and later on when we will automate and put the whole thing under one function, we will put it always as very fast. So we do have low speed, medium speed, fast speed, and high speed. So we will set up it always as 11, sorry. But for the moment, we don't need to change it. Then also for the pull up, pull down, this is also needed for some specific application, but for the moment we are not going to set up none of them. And here you do have the values pull up and pull down, or none of them. So 1 is not a value that we can use. So here, this is the port input data, and this is what we will see later when we will set up our pin as an input. Then finally, we go to the GPIO port output data register. And this is the register that will control the state of the pin as a high or low or on or off when we change it. So let's go quickly and go back. So that's the ODR or the output or the direction register. So if I put GPIO A, and then we do have ODR like this, and we put or equal, and we just put 1 because it's the bit number 0. This one should set PA0 to high or on. Okay, so let's save, build, zero error, zero warning. Fantastic. So let's bring here our video, and the PA0 is connected to the LED, the red LED. So if all works well, if I load now my code, the red LED should turn on. So let's Okay, and I have an error message because I didn't connect my device, and that's normal because I started this program from scratch. So to connect my device, I go to the debug tab and I select the ST-Link. I'm using for this program, to program this microcontroller, the ST-Link. Then I go to setting, go to flash, reset and run, and I go to the pack tab and select enable. Put OK. Okay, I just before closing it, if I go to debug and setting, I should see the reference of my ST-Link and also that is connected directly with the microcontroller and can read the reference. Okay, let's load now. And we do have the red LED turning on, which is exactly the state we needed. Perfect. So let's jump now. So we turned on, and now we can jump to the next step where we are going to turn on the PB7. So instead of really stopping and going through the details, PB7 is a little bit different, or we are going to add a little bit of complexity because this one, the PA0 was the pin 0. And now we are going to change the GPIO port and also have a pin which is a little bit further so we can apply more general method to set up this pin. So again, we go quickly to the port, the RCC register, and we found that everyone is connected. Every GPIO port is connected to the AHB1 enable register. So let's find it, AHB1 enable register, and the port B is the bit number 1 of the GPIO, not this one. This is the reset, and the enable, this is the enable register, GPIO enable register, and again it's AHB1 enable. To do so, what we can do, we can just copy this one and we can put here 1 1. Okay, or even like this one is just a recursive or we are repeating ourselves. Let's try to be dry. If I do 1 1, I'm enabling also the register, the GPIO B peripheral, or also I can write here an hexadecimal of 3, and here it becomes as a comment we are activating or enable the port A and B. Okay, good. So let's, we don't need this one anymore. And after that, if we would like to focus, we can repeat almost the same thing. So let's copy this. Let's copy this here and make it a little bit more automated. So just to not confuse everyone, I will add a line here like this, and we are going to start setting up the whole thing. So here is PB7 and enable. Okay, so let me hide the camera now. Okay, so you can see the picture. So I copied back all this GPIO A, and what I need to do first, let me change into B because it's exactly the same thing. Port A, B, C, until H, or until the number of the microcontroller do have the memory already allocated within this library. But here, I'm looking for the pin 7. And to go for this one, if I go for the mode register, let's go back here and take a look to the mode register. And we would like to use a good binary operation. So the number 7, the pin number 7, is controlled from both the bit number 14 and 15. And as a formula perspective, I can use the same thing here and just pushing as we offset by 14. So by offsetting this bit by 14, I will be closing, or I will be resetting those 2 bits. Then same thing happening here. I just because, but yeah, 14. So I move this one also by 14. And just let's make our code a little bit more interesting, or to see the different way to write the code. If I write sorry, this is a 1 hexadecimal, it's also 1, it's the same thing. So if I put a hexadecimal 1 and I push it by 14. And this one, I'm putting up 7, the pin 7. And why 14? Just it's 7 multiplied by 2. And we need to, just in case, put them between parentheses. So we are pushing 7 because it's pin number 7, and multiply by 2 because it's a 32-bit register controlling a 16 pins. Okay, and then same thing here for the output type. We would like to reset the one in the position number 7. So we just, again, we can push this one by 7 bits like this. Okay, and here this is 3, not 1, sorry, because it's 1 1. So we would like to reset the 2 ones. Okay, but here it's only 1. And finally, for the ODR, same, we just push it, sorry, just push it by 7. That should make everything okay. Let's build and check. Looks good, no error, no warning. So let's bring back the video like this and load our program. Okay, so both LED are now working properly, which is fantastic. So you see now it's just, we are going to use again the same pattern to make for the next pin. So if we go here, and I will not do the same mistake, and I will hide the video. So now we are going to turn on the PC13 LED. Okay, so if we go back, again, we are repeating again, and we just repeat so we understand it's automatic. It's very simple to do, and you are seeing it. So this one, the GPIO enable, is the pin or the bit number 2. So let's go back to our program here. And if we would like to add it here directly, so it means it's a binary 111, or from hexadecimal perspective, we can just, or even decimal, we can put 7, and this one, and C. You get it now. So let's copy the whole thing like this. Yeah, and we do have a warning. I will need to find why. So why we do have a warning here. Let's check it within block comment. Okay, understood. So I forgot to add this one, so it should clean it. Perfect. So now we are enabling the PC13. PC13 is an embedded LED within the board. So it's a small LED inside the board, and we should see it. It shines quite strongly. So we enabled the GPIO, and now we are going to manipulate the GPIO here. So we change B to C. We are repeating ourselves, but it shows us a certain pattern. And instead of having 7, it's 13. We would like to enable the bit number 13. And here, I think we should put 26 because it's 13 multiplied by 2. But let's put it 13 multiplied by 2 just to show the repeated pattern. And here just 13. And after that, here only 13. So let's save and see the okay, 0 error, 0 warning. Let's bring now the camera and see the result. Okay, so we do have a red LED, but that one is the power LED, and the LED is not shining. Actually, for the board itself, this is because the LED in the board is an active low, which means this LED will be working when the pin is turned off. So if I just remove this one like this, and if I do save here and build, so just I commented the last one that set up my pin as high and loaded, you can see that the LED pin on the board is now shining or turned on. This is because it's, as I said, it's a active low. So it's kind of the fridge. It's opening just when you open the door. Okay? So that was the way that you can see how you can turn on or off the LED. So we were able to control the pin state from scratch. So now it's a good time to have a summary. First of all, we started by enabling the specific GPIO port using the RCC register. Then we set up our target pin within the GPIO itself as an output. After that, we checked that that specific pin is not in open drain state. Finally, we set up our pin high or low depending on the requirement that we needed. And the last point, we had some issue with the final LED, the PC13, and this is because within the circuit it was an active low. So we needed to confirm our PCB layout to understand the electrical circuit that we are working with. So that was all for today's session. Really, thank you again for watching the whole video and see you in the next episode. Bye bye.